lessons 5.5 and 5.6, and then some problems from the worksheet that you did. And your goal, or the target, the task you'll be learning is comparing graphs of linear and nonlinear equations using rate of change, which, as a reminder, is your slope. So we're going to be focusing on that. Okay, this first problem is from lesson 5.5. The number of devices a particular manufacturing company can produce is a function of the number of hours spent making the devices. On average, 4 devices are produced each hour. Assume that devices are produced at a constant rate. So that's important. 4 devices each hour. And it says the number is a function of the hours spent. So that means hours is our x and the number is our y. Because as a reminder, y is a function of x. So for the first part, letter A, write an equation in 2 variables that represents the number of devices y as a function of the time the company spent making the devices, x. So they just told us that again, that time is x and number of devices is y. So I labeled x equals time, and that's 1 hour, y equals number of devices, and that's 4. So if you remember, my slope is the change in y over change in x, so it's y over x. So here, my slope is going to be 4 over 1, which is 4. So my equation is y equals 4x. Letter B, use the equation you wrote in part A to determine how many devices are produced in 8 hours. So I wrote my equation up here, and 8 hours is time. And if you remember, x is time and y is number of devices. So if 8 hours is time, I'm going to plug it into my equation. So y equals 4 times 8. So y equals 32. So 32 devices are produced in 8 hours. Letter C, use the equation you wrote in part A to determine how many devices are produced in 6 hours. So same thing, y equals 4 times 6 now. So 24 devices are produced in 6 hours. Letter D, use the equation you wrote in part A to determine how many devices are produced in 4 hours. So y equals 4 times 4, 16 devices in 4 hours. The input of the function x is time, and the output of the function y is the number of devices produced. I'm going to label that right now. Okay, I also rewrote my equation, and x is time, y is number of devices. Write the inputs and outputs from parts B through D as ordered pairs and plot them as points on a coordinate plane. I made a list of the coordinates from the previous problems in green. I plotted the points as green dots, and I drew as straight of a line as I could. What shape does the graph of the points appear to take? And it's a line. You could even say it's a straight line. But when we refer to a line, lines by definition are straight. Is the function continuous or discrete? So those are 2 important vocabulary words. As a reminder, continuous can be split up, and discrete can't be split up. So things you can't split up are people, cars, buses, things like that. Things you can split up are money, time, liquids, distances. So things written in red are continuous. Things written in yellow are discrete. So, in this case, the function is continuous because we can find the number of devices produced for any given time, including fractions of an hour. So sometimes that can be confusing, but in this case, that's the answer. Letter I, assume you use the rule that describes the function to determine how many devices are produced for any given time and wrote each answer as an ordered pair. Where do you think these points would appear on the graph? So they would all appear on the line. Letter J, what do you think the graph of this function will look like? It'll look like a line. And the rate is continuous, so that's why it's a line. And the devices are produced at a constant rate. So it's a line. Connect the points you have graphed to make a line. Select a point on the graph that has integer coordinates. Verify that this point has an output that the function would assign to the input. So I see that 520 might be on the graph. So I plug it in. Y equals 4 times 5. The y is actually 20. Is 20 4 times 5? Yes. Sketch the graph of the equation. Y equals 4x using the same coordinate plane. What do you notice about the graph of the function that describes the company's constant rate of producing devices and the graph of the equation? They're the same. They're both lines. So the main idea here is that the graph of the function and the graph of the equation are the same, and that the graphs would coincide, or they would be on top of each other, because they're the same. Okay, this is from lesson 5.6. A function assigns the inputs and corresponding outputs shown in the table below. So what I labeled was the rate of change for my inputs, which are x, and my outputs, which are y. So all these are the change in y, and all of these are the change in x's. And I found those by subtracting this smaller input from the larger input, or the smaller output from it's not smaller, the first output from the second output. So letter A, is the function a linear function? Check at least 3 pairs of inputs and their corresponding outputs. So my slope is change in y over change in x. So I have negative 3 over 1, which is negative 3. I have negative 6 over 2, which is negative 3. And I have negative 6 over 2, which is negative 3. So they're all the same. So yes, it is a linear function. What equation describes the function? So my m was negative 3. Okay, I rewrote my values. Okay, so finding my change in y over my change in x, I found the slope is negative 3. So now I'm going to test it and see if it works. 2 equals 1 times negative 3. Is that correct? That is not correct. So it doesn't work, so I need to plug in a value for b. So 2 equals 1 times negative 3 plus 5. I would go plus 3 to solve for that. I would get 5 is what works. This would be B, so B is 5. So my equation is y equals negative 3x plus 5. And I would test and see if it works. And when I plug in x and y values from here, it does work. And the graph will look like a line. The rule y equals 1, 2, 3x is used to describe the function for the number of minutes needed, x, to produce y toys at Toys Plus. Another company, Number 1 Toys, has a similar function that assigns the values shown in the table below. Which company produces toys at a slower rate? So which one is slower? So I labeled my table Number 1 Toys. So I labeled my table Number 1 Toys and my equation Toys Plus. So if my equation is y equals 1, 2, 3x, my slope is 123. And now I need to find change in y and change in x in my table. So when I found my rise over run, or my slope, I did change in y over change in x, and they were both 120. So my slope for Number 1 Toys is 120. Now I'm going to compare those two slopes and see which is greater. This slope is greater, so that means that the slower slope is Number 1 Toys. So Number 1 Toys produces toys at a slower rate. Number 1 Toys is slower. And lastly, a function has the rule so that each input of x is assigned an output of x cubed. So y equals x cubed. Is the function linear or nonlinear? So I'm going to look at my exponent, and it's greater than 1, so it's non-linear. Now using that rule, input x, output is x cubed. I'm going to fill in values. So using my calculator, I filled in all the y values. I'm going to answer the questions. Plot the inputs and outputs as points on the coordinate plane where the output is the y coordinate. So x and y, I'm going to fill in those values on my graph. Okay, so I plotted my dots the best I could on this. And what shape does the graph of the points appear to take? It's definitely a curve. If I followed it, it would do kind of a curve this way and then curve up. So it's like that. It's definitely not linear. So these concepts cover the main ideas of week 27, and your test next week will be weeks 25, 26, and 27.